All right, 7.3, least common multiple. And like yesterday's notes with greatest common factor, we just abbreviate this with a LCM. Pick the first letter of each of the words. And this, what we're talking about, is it's going to be the smallest non-zero common multiple. So multiples of 5, you could say are 5, 10, 15, 20, ... Multiples of 3 would be 3, 6, 9, 12, 15, 18, and so on. So least common multiple is going to be, look here, the first number, the smallest number, the least number that they both have as a multiple. So least common multiple is the smallest number that is a multiple of two different numbers. And I suppose we could have three different numbers in there, so it's the least common multiple of more than one number. So we're going to do this two ways. The first way, if you did Math 7 last year, it's going to be kind of the way we did it last year. And then we get to the prime factorization, the factor tree, in a way that's much slicker. I think that's cool. But for small numbers or easy numbers like this example 1, 4, and 5, the easiest way to get it is going to be just to list the multiples. In hindsight, maybe it's not the easiest way. The other factor tree might be even easier for this. But I'm guessing a lot of you look at that and say, boom, the answer is 20. And it is. If you look, in my example I had before, I was kind of scrunching together the numbers here for the smaller one. I've had people that list them out, and then they totally miss that two are that something's the least common multiple. So what I'd recommend doing if you're going to do this is start with a smaller number, and 4, 8, 12, 16. You might remember a calculator shortcut where you can do the number equals and then plus to get the answer to pop up, and then that number again, and just keep hitting equals. You can do that with tough ones. But now when I have my 5, I'm going to kind of line my numbers up below it. So instead of doing like 5, 10, 15 like this, and then 20 and having to connect things over, if you have a long list, it's going to be easier to see if you take and say, all right, my 5 is right about there, kind of between the 4 and the 8. 10 would be there, 15, and then 20. Boom, you can see that it's 20. So least common multiple is just going to be a 20. But if you line them up like that, it's a lot easier to not miss. All right, prime factorization. Going back to the factor trees like we've been doing the last 2 lessons. For this, if you forget which one's which, like what do you do to find GCF, what do you do to find least common multiple, as long as you can remember what they are, do one. If your number is smaller than the original numbers, you just found the greatest common factor. If your number is larger than the original numbers, you just found the least common multiple. But I kind of got the cart ahead of the horse a little bit. To find this, once you do the prime factorization, then you multiply the highest power of each prime number. So where before we only did what they had in common to get greatest common factor, for least common multiple, you multiply the highest power of every number that's included. All right, so what in the world does that mean? Let's do an example, and that will make this, hopefully, as clear as glass. That's not fogged up and all that stuff. Okay, 45. 9 times 5 is 45, so I'll do my 5 in front so I can see that as prime a little easier. And then my 9 I can break up, and I have a 3 and a 3. So this gives me a 3 squared times 5. By the way, if this factor tree stuff is tough, flip back to the section 1 notes. I'm not really explaining how to do it here. I'm just kind of busting through it real fast. All right, 120. So I'm going to take and divide that by 2 first. So half of 120 is going to be 60. And you could do 30 times 4 or something like that if you want to instead. But I'm going to keep going with the 2's. So half of 60, I can do that in my head easily. So I'm going to write that as a 2 and a 30. And I can do half of 30 in my head pretty easily. So and then I make a mistake, wouldn't you know? Okay, 2 times 15 gives me 30. Then, nothing like bragging than getting it wrong, huh? 15 is 3 and 5. All right, so I have my prime factors there, and there's a bunch, so maybe I'll circle them as I go. So I have a 2 to the third, times only 1 3 and 1 5. All right, so now I have these. So what in the world do we do with these? We want least common multiple. You find the highest power of each prime number. So I have a 2 to the third, and that's my highest power of 2. So part of my answer is going to be 2 to the third. So maybe I'll do a LCM equals 2 to the third times. Now I have a 3. I have a 3 squared and a 3. So I just keep the highest one. I have a 3 squared. So I'll do right times 3 squared. And I look at my 5s. I have a 5 and a 5. So 5 to the first, 5 to the first. So I just keep the highest, which is 5 to the first. And so you'll notice I have a couple different things there. I picked, well, what's one that only shows up in 1? So 2 to the third, well, if it only shows up in 1, I still keep it. It's the highest. If I have one that's in both, I have a 3 squared and a 3, then I just keep the highest power, the 3 squared. And if I have one that shows up in both and the power is the same, then I just keep that power. All right, so a lot of you will probably just punch this in your calculator, 2 to the third times 3 squared times 5. If you want to do it, you could punch it all in, hit equals, or you could do it by hand. So 8 times 9 times 5. So a 72 times 5 or 8 times 45. Anyways, punch in your calculator. It'll give you 360. So I think that's way cooler than having to list out all the different numbers, especially when you start getting like 3 of these things, like 3 numbers you want the least common multiple, like this one. All right, so if we do this here, least common multiple, I have an 8. So 8, 2 and 4, 2 and 2. So that's a 2 to the third. 18. I have a 2 and a 9. And 9 I can say is a 3 and a 3. So 2 times 3 squared. And at 87. Yuck. 87. So I could look at my divisibility rules. I can't divide by 2. Could I divide by 3? 8 plus 7 is 15. Yup. Because I could divide 15 by 3. I know I could divide 87 by 3. So 3 and something. Honestly, I got a whole lot of nothing when it comes to that. So, all right. So that gives me 6. So 27 and 9. Okay, so 29. And that should be prime. Can't divide by 2. 2 plus 9 is 11, so I can't divide by 3, which means I couldn't divide by 6. Can't divide by 4, because that'd be 28. Can't divide by 5. Can't divide by 7. 8. Can't divide by 8. Can't divide by 9. Yep, so that must be a prime number. So we have 3 times 29. So 3 times 29. So now if we want to figure this bad boy out, all right, if I look at my 2, I have that and that. So I keep my 2 to the third. Then I have a 3 squared and a 3, so I keep my 3 squared. And I keep my 29. So 2 to the third times 3 squared times 29. If I punch that in, it gives me 2,088. So final answer, 2,088. All right. Very last one, 12 and 15. Write this with least common denominators. So we could go through and do either one of those methods. I'm maybe just going to list them. So I'm going to say 12. Pull up a pen. So I'll have a 12 and a 24 and a 36 and a 48. Plus 2 is 50. Plus 10 more is 60. 72, dot, dot, dot. All right, my 15. So I have 15 and 30, kind of lining the things up. 45, 60. Perfect. Okay, so 60. So you could do that. You could go back and do the factor tree one if you wanted to. But let's see. So for my 12, this one here is the, if I count over, I have 1, 2, 3, 4, 5. Fifth one in the list. So I could multiply by 5, and that's going to give me 60. And multiply the 1 by 5 to keep it so it's an equivalent fraction. So I have 5 over 60. And then for my 15, I had 60 was the fourth one over, so I'm multiplying by 4. So times 4 times 4. So that would give me 8 over 60. And then you could go on and so on. So the parentheses, find the least common multiple of the denominators. And then use equal ratios from there. That's all I got. Let me know if you have questions.